Okay, this is the algebra packet, days 11 through 15. And this is for the phase 2 packet. Again, I'm going to do a full week at once because I'm not going to do every single problem. All this we've already covered, so you should feel pretty comfortable. Some of the examples that they give you, the methods of doing it, a little bit different than we did in class, but again, it's fine, it works. So if that makes more sense to you, and it didn't make sense before, then please use this. Okay, so yeah, the method that it states is definitely different than what I do. So I'm going to do it the way that I taught you all, and let's do maybe one of these upper examples and maybe a word problem. So we're just adding polynomials. The biggest problem that I see is when there's a subtraction and we kind of forget to apply that to all the terms inside of the second polynomial. So I'm going to do number 5. So when I do this, I like to use distributive property to get rid of parentheses. So the first set of parentheses, if there's nothing in front, we can just drop those and rewrite what's inside exactly as it is. Second set of parentheses, if there was a plus, then we could just write it out as it is, but there's a minus. So I'm going to put a 1 there. I'm going to treat this as a multiplication. So basically I'm going to take that negative 1 and I'm going to multiply it to each of these terms inside. And then what that's going to do is change the sign of each of those. But we're not just memorizing changing the sign. We're thinking, okay, if I have a negative 1 times a positive 5, that's going to give me a negative 5 or minus 5. If I have a negative 1 times a negative 7a, that's going to give me a positive or plus 7a, and that should not say squared, just 7a, okay? And then another thing to note is we're not solving, we're just simplifying. We're not solving for a in this case, we're just simplifying. So we're going to look for like terms now that we don't have parentheses. So I'm just going to highlight some of our like terms. So I have an a squared, so I have 5a squared, and then I have negative 7a squared. I have a positive 6a and a positive 7a, so those are going to give me the things I'm going to combine, and then a positive 2 and a negative 5. So let's see what we get when we combine all those. So my a squareds first. So I have a positive 5 and a negative 7, so it's going to be negative 2a squared. And then the a terms, I have positive 6 and positive 7, so it's going to give me positive 13. And then the numbers, the constants, I have positive 2 and a negative 5, so it'd be negative 3. And that's it. So we just simplified, we're not solving. Again, just be careful with when you're subtracting, and then make sure you're combining like terms correctly. Okay. Let's see here. I'm going to do number 8. So it says the measures of two sides of a triangle are given. Okay, that's our diagram. If P is a perimeter and P equals 10x plus 5y, find the measure of the third side. So a couple things. First of all, what does the perimeter mean? Okay, so that's the distance around. If we start here, we go around, so that whole distance, if we're measuring it. Okay, so that's the perimeter. We have 2 of the sides, and we need to find that third side. Okay, so let me just write out. So how would we calculate perimeter if we just had numbers? We would just add all those sides together. So 3x plus y plus 4y, and then plus 5x minus y, and then we would add something here, and then that would equal the perimeter. Okay, so that would equal, and the perimeter they give us is 10x plus 5y. So I don't want to put another variable, okay? So what I'm going to do is I'm going to isolate that question mark. So that's what we're trying to find. So what would I have to do so that I have something that has the question mark by itself? So think about when we solve equations. I want to solve for the question mark. So I'm going to take all of this and I'm going to subtract that on both sides. Okay, so if I do that on the right side, I'm going to subtract all of that I have on the left. Okay, so just check it again. So I'm subtracting 3x plus 4y plus 5x minus y. Okay, so if I subtract that on both sides, then all this would be gone. So I'm not going to, I mean, it's, you know, I want to write that all down here. So I'm going to subtract it. So that basically makes 0. So now whatever the third side is, that question mark, that's what we're going to have on the left. Okay, so now if we simplify what's on the right side, then we will find our missing side. I mean, I could call it b or something, but I don't really want to add another variable when we already have 2 variables. So let's see what we get over here. So 10x plus 5y. Again, we have this negative, so put a 1 and just think about we're going to multiply a -1 to each of these terms inside using distributive property. Or we could combine like terms inside the parentheses first and then multiply the -1. It doesn't really matter the order. I'm just going to multiply. I'm just going to get rid of those parentheses right away. So I have minus 3x minus 4y minus 5x plus y. Okay, now I'm going to combine like terms. So I have x terms. Oops. I have x terms, including the signs, and then I have y terms. Okay, so let's see what we get when we combine the x terms. So I have 10, positive 10. So 10 minus 3 is 7, minus 5 is 2. Okay. Again, think of it in a different way. I have 8 total negatives, and I combine that with 10 positives, so that leaves me with 2 positive. Okay, and then the y, we have 5 minus 4 is 1, plus another 1 is 2. Okay, let's put the positives together first. So 5 and 1 is 6, minus 4 is 2. Okay, so our missing side is 2x plus 2y. And remember, when we add those 3 sides together, we're going to get 10x plus 5y. So let's just do that in our heads. 3x plus 2x plus 5x, that's 10x. Okay, 4y plus 2y is 6y, minus 1 is 5y. So it is correct. All right, let's keep going. Okay, so here's a challenge. This Open Middle is actually a website. You can go and there's all kinds of really awesome, they're not really like brain teasers necessarily. I mean, they're really testing or challenging your understanding of, in this case, subtracting polynomials. So again, thinking about what happens when we have this little negative here. What does that do to the sign of the terms in that right-hand expression? So you really have to think about it. Again, you may just start off with kind of guessing at first, but then the more you do, the more you understand, okay, well, you have a much smarter place to start than just, for example, just putting in 1, 2, 3, 4, 5, 6, right, and so on. So again, think about it. Leave a comment in Google Classroom or a comment or a question in the comments of this video, and if you're stuck. Okay, the next day, multiplying polynomials by a monomial. So it's kind of like we did with the negative 1 in front. We just multiply it to each of the terms inside. So it's just the same. And then if we can combine like terms, but it looks like these, there aren't going to be any like terms to combine. So I'll do one, then I'll leave the rest up to you. So I'm going to do number 3. Okay, so I have negative 2xy times 2y. So that's negative 4x. And then we have y and a y. So y times y is y squared. And then I have negative 2xy times positive 4x squared. So that would be negative 8x to the, so this is first power times x to the second power. When we multiply powers, we add exponents. And then there's no other y besides the one out here. So that's it. All right, so just be careful of your exponents. The other ones, there's one variable, so you don't have this 2 variable like we just did. I'll do one more, number 6. So I have negative 4x times 2x cubed. We get negative 8x to the 4th. Then negative 4x times negative 2x, we get positive 8x squared. Then negative 4x times 3 is negative 12x. Again, we're just simplifying, we're not solving. All right, next thing. Okay, so we have a table, and it looks like we have an expression here, 1/2 times n squared plus n. All right, and it says this expression is the sum of the first so many whole numbers. All right, so let's just see what this is. So the n's are given to us. We're going to start with 1. And it says to expand the equation, or expand the expression, by multiplying and then finding the sum. So we're going to multiply using distributive property. So I have 1/2 n squared plus 1/2 n. And then find the sum. Okay, so if I put a 1 instead of n, 1 squared is 1, so I get 1/2 plus 1/2, which is 1. Okay, and then if I put a 2 there, I get 1/2 times 2 squared, which is 4, plus 1/2 times 2. So what is that? Half of 4 is 2, plus half of 2 is 1, so that's going to be 3. All right, so let's think about what this explanation said. This is the sum of the first n whole numbers. All right, so if I'm at 2, if I'm counting and I have 1, we just started at 1, so we have just 1, that the sum is 1. If we get to 2, then the sum of 2 and 1 is 3. So then what do we think this next term is going to be? 3 plus 2 plus 1, so it should be 6. Let's see if that's right by working this out. So we have 1/2, and then 3 squared is 9, plus 1/2 times 3. Now, this is what it said to do. Multiply and then find the sum. But you don't have to. You could always just leave it and then use use order of operations, simplify inside the parenthesis, and then multiply by 1/2. So when we have odd numbers, like 9 and 3, it's going to be a lot easier just to do it this other way. So let's try it this way. So 1/2 times, so we get 9 plus 3, which is 12. Half of 12 is 6, and that's what we thought it was. All right, so try a few more and see if that does work. I would even, open up Desmos and graph this expression, see what it looks like. I would hope that you have an idea based off of that exponent, what it's going to look like, because we've done these. So anyway, if you have any questions, again, just leave a comment. Okay, moving along with polynomials. So just like we did in class, we added and we subtracted, we multiplied by a monomial, and now we got to our binomials. So this was what we started doing as we introduced quadratics. So again, it's just practice doing that. The examples, they call this horizontal method. I call it double distributive property. So that's the way I did it in class, and that's the way I prefer. And you'll see as we get further along in this packet that this is the only way that's going to work all the time, whereas the FOIL method it only works for binomials times binomials. So I don't use it. I don't say it. I don't use it, even though it's the way that I was taught. It's just very limited. So again, I would prefer you not use that because as you'll see on day 15, it doesn't work. So I'll do one real quick, and you guys are really good at this, so I'm not going to spend a lot of time. All right, so number 2. So double distributive property. So x times negative 2. And then negative 4 times x, and negative 4 times negative 2. So that's what we're going to do. All right, so x times x is x squared. X times negative 2 is negative 2x. Then we go to the second term. Negative 4. Remember, we're including that sign, so be careful with that. So negative 4 times x, negative 4x. Negative 4 times negative 2 is positive 8. Combine like terms in the middle. So we get x squared minus 6x plus 8. How could you check your work? You could, a couple things. You could graph in Desmos, leave it with parentheses, and then leave it as your answer and see if they match. It should be the exact same curve. If they're not, check your work, maybe multiply by negative incorrectly. Another way to do it is to substitute a number. So choose any number for x. Put a 0 there. See if we get the same answer. So there's lots of different ways to check to see if you got it right. Or you could listen to this video. Okay, here we have some basically word problems, practicing what we just did. So let's see here. Number 1. The loft theater has a center seating section with 3C plus 8 rows and 4C minus 1 seats in each row. Write an expression for the total number of seats in the center section. Okay, so most of us have been to some sort of event where there's lots of different seating. It could be a football game, it could be anything, church even. But anyway, a section of seats. Okay, rows and columns, right? So different rows, different numbers of seats in each row. So how would we find the number of seats? In this case, what is that? 4, 1, 2, 3, 4, 5, 6. 6 rows, 4 seats in each row, 24 seats. So how do we do that, right? So think about that. Always try an easier problem to get the understanding of what to do and then apply it to the one with all the variables. Okay, so basically what we have to do is take this, that's the number of rows, times the number of seats in each row. Okay, so 3C plus 8 times 4C minus 1. Okay, so just like we did before, 3C times 4C is 12C squared. 3C times negative 1 is negative 3C. 8 times 4C is 32C. And then 8 times negative 1 is negative 8. Combine like terms. I'm going to write over here 12C squared. And then negative 3 plus 32 is plus 29C minus 8. All right, and again, just go through, check to make sure that it is correct. Again, you can use Desmos and graph both of those expressions and see if you get the same curve. Now, is this a very realistic problem? No, because we would not be given rows with a variable. Now, on the other hand, if you were designing a theater and you wanted to be able to graphically or mathematically adjust different configurations for the seating, like it's just an open space, you need to figure out what the best combination is. Now, you might want to write an expression like this and play around with that variable and see what works the best in your space. But if this is an existing theater, you would know how many seats in each row. You'd know how many rows. You'd multiply that and you'd be done, right? So again, just a little bit different application, but it could be used in a different type of problem. Okay, so the rest, I'm going to let you go through. And again, if you have any questions, just post a comment either on the video or in Google Classroom. Okay, another open middle math problem. So I have comments open in Google Classroom. If you want to, collaborate with your classmates, that's fine. Ask me questions. Take a picture, post your solution. You can even post a link to a Google Doc or something in this video if you want me to look at it. Okay, day 14. Continuing along with polynomials, we have basically a square, right? One side times the same side, area of a square. And this is one of our special products that we looked at. And the graphs are interesting when we look at these graphed out. So same thing, right? So I'm going to do one or two and then leave the rest up to you. So the first thing that I do is just write it out instead of with an exponent. I'm going to write it out like we normally would. So it's just a little bit easier to see. And then I'm going to just use distributive property twice. So x times x is x squared. X times negative 6 is negative 6x. And then we take that negative 6 times the other two terms. We get negative 6x plus 36. Combine like terms, we get x squared minus 12x plus 36. Now, the more of these that you do, the more you're going to kind of realize that there's possibly a shorter way to do this. And that's fine, right? But I don't want you to memorize anything, any gimmicks or anything. I want you to know how to do it all the time, even if you forget those other shortcuts. So let's look at one that's maybe not so nice. So like number 9. So 2p plus 4r times 2p plus 4r. So 2p times 2p is 4p squared. 2p times 4r is 8pr. And then this next one, we go to the 4r. So we could think of it as 4r times 2p. That's 8rp. But we can rewrite it because of the commutative property. So I'm just going to, instead of rp, r times p, I'm going to write it as p times r. Just so it looks like what we did on this one. And then 4r times 4r is 16r squared. So I'm going to combine those two middle terms. We get 4p squared plus 16pr plus 16r squared. Okay, so yeah, again, if you're thinking about, okay, what's the shortcut? Okay, so let's look at these numbers that we started with. So we square the first one, okay? Square the first one, we get 4p squared. Okay, we square the second one, we get 16r squared. All right, and then we multiply those together, and we get 2p times 4r, which is 8pr, and then times 2. And that'd be 16pr. Okay, let's see if that works for the first one that we did. So x squared, yes. Negative 6 times negative 6 is positive 36, okay. Negative 6 times x is negative 6x times 2 is negative 12x. So that works. Again, do you want to memorize that? Not really. Just know how to do it, expand it out, use distributive property twice, and then you'll always get the correct answers. No need to memorize any shortcuts. Okay. Again, some word problems, practicing what you just did. Let's try, number 2, geometry. It says, Janelle wants to enlarge a square graph that she has made so that each side of the new graph will be 1 inch more than twice the original side G. What trinomial represents the area of the enlarged graph? So the trinomial is basically what we ended up with, right? 1, 2, 3 terms, so it's a trinomial. So that's what we're looking for. Okay, so we need 2 things to multiply because that's what we've been practicing. But if we didn't know that, if this was just a problem that we were presented with, it says area. So area is length times width, or side times side, and it's a square. So it is side times side. So that's helpful. And I'm just going to draw a picture. It's a little bit easier to imagine. So we're going to enlarge it. All right. The original side G. So this is G times G. So G on all sides. So the area of this would be G squared, right? Okay, so the new area, or the new side, is going to be 1 inch more than twice the original. So 1 inch more than twice the original. Okay, so what is the area of the enlarged graph? Okay, so we find the area by multiplying the sides together, or sides squared. So in this case, it would be 1 plus 2g squared. I'm going to expand this. Okay, and then again, distributive property twice. So I get 1 times 1 is 1. 1 times 2g is 2g. Okay, now I have this 2g times 1 is 2g. And then 2g times 2g is 4g squared. Need a plus sign. And I'm just going to rewrite this with the highest power first, like we normally do. So this would be 4g squared. And then combine those two middle terms. 2g plus 2g is 4g. And then plus 1. So again, if it's confusing, choose a number. Okay, let's say, you just put a 1 in there, and then see if, draw it out and see if it's, so if our original side was 1 inch, and, well, actually, it doesn't tell us how much of an enlargement we want, right? It doesn't say that we want to double or triple the size of this. Nope. But a second step to this problem could be that. So we could say, okay, now let's say the original square had a side length of 3. What is the dilation factor or scale factor that we use to enlarge it? So how many times greater is it? So that'd be interesting. But again, it doesn't ask that, so we'll leave it at this. Okay, so the last thing with polynomials. So this is where I said, if you memorize FOIL and that's all you know, it will break down on these types of problems. So we have a binomial times a trinomial, and eventually you're going to have a trinomial times a trinomial. So FOIL method doesn't work, and I was only taught FOIL method, so it took a long time before I realized that there's another way, and it was very frustrating. So I wish my teacher would have not taught me FOIL method. All right, so let's find one that looks kind of messy, and let's do that together. So let's just say number 6. Okay, so I'm going to take 2t times this, times this, times this, and then second distributive property, 1 times each of those. Okay, 2t times 10t squared. So 2 times 10 is 20. T times t squared is t cubed. 2t times negative 2t is negative 4t squared. And then 2t times negative 4 is negative 8t. Okay, we keep going. So then this is kind of nice though. 1 times each of these is just those things. So we just write them again. Make sure we have our signs correct. All right, so now it's just a lot of combining like terms. So t cubed, there's only 1, but here's a t squared term, another t squared term, a t term, 2 of those, and then there's just 1 constant. So 20t cubed, and then negative 4t squared and 10t squared, that would be positive 6t squared. And then negative 8t and negative 2t is negative 10t, and then that negative 4. And that's it. Again, how can we check our work? In Desmos, type that in, and you should get the exact same graph. And actually, these graphs we haven't looked at yet in class. So it'd be kind of interesting to see what they do look like. You will see these in high school, though, for sure. All right, so that's it. So 2 distributive properties. Again, we could do as many terms times as many terms as we need. And it's going to be the same. It's going to be just distributive property, however many times we need to, so that we multiply all of the first terms times all of the second terms. Okay. Again, word problems to practice what we just did. All right, number 1. Linda has a garden. It's a rectangle, and the sides are 3x minus 5, and the other side is 2x plus 8. She wants to put a fence around the perimeter of the garden. If each foot of the fence costs $5, how much will the total fencing around the garden cost? Okay, so let's figure out the perimeter of the garden. That's what we need to know, right? Okay, do we know anything about the area? Does it say anything about the area? It doesn't. So we're not even multiplying. We're just adding these together. So again, I'm just draw a picture here. 3x minus 5, 2x plus 8. Okay, so perimeter, it's distance around. So I could write it as an expression, 2 times each side, and then add those together. 2 times 3x minus 5 plus 2 times 2x plus 8. And that's the perimeter. Okay, so we get 6x minus 10 plus 4x plus 16. And combining like terms, I get 10x minus 6 equals perimeter. Okay, so that's our expression for the perimeter, 10x minus 6. If each foot of the fence, so this is all in feet, 10x minus 6 feet. Okay, so think about that. Each foot of the fence cost $5. How much will the total fence cost? So each foot, so this is basically in feet. That's how many feet. So let's just say it was 15 feet. Let's just make it easier, 10 feet. So the perimeter turned out to be 10 feet. Each foot cost 5. 10 times 5, that's $50, right? But we don't have that. So this expression is how many feet. So we just need to multiply. So the total cost is going to be 5 times all of this. And that's going to be the cost. Okay, so it's 50x minus 30. And in a kind of awkward way, we could write that as dollars. So we don't know what x is. As soon as we do know what x is, then we would know if x is 1, for example, then it would cost $20. If x is 2, then it would cost $70. So again, we can't really answer the question, and I have a feeling there might be a typo or maybe a piece left out. But at any rate, this is the best we can do. And again, not a wonderful problem, but this could be another planning type method or planning type problem. So you're a landscape company, you have some options, you maybe want to maximize the area, but minimize the cost of this fence. So you could find the area. And this is the kind of stuff that we would be doing right now if we had class. Looking at area versus surface area, or volume versus surface area, area versus perimeter. Like, how can we adjust these so that we make the most efficient space possible? So this would be the area. So we would multiply this out. We would get a quadratic. So if we want like the maximum area, okay, so this would come out to be, okay, so is it facing up or down? Okay, it's going to be a positive coefficient of x squared. Okay, so let's just say it's something like this. So that's our area, all right? And then we have this line that represents cost, or maybe perimeter. Well, cost is fine. So we have, you know, some different points of intersection to look at, or different regions to look at, like anything in between here. So what does this all mean, right? So that's what kind of conversations we would be having. What does this mean? So what do these points represent something? Okay, and what do they represent? Is it intersecting at all, right? So we would look at different things like this and see if we would come up with some actual solutions, some recommendations. So again, if we were a company, we're trying to save the customer some money, offer some options, you know, we would need to consider things like this. All right, so that is it, except for the last little challenge that you have. And again, we've done lots of these, so I'm going to let you go ahead and do this. If you're stuck with the equation part, you know, just leave a comment or reach out. All right, that is it.